Hello everyone, we are from Group 3, Section 4. We'll present to you Chapter 1, Chemistry, about fundamental of chemistry and atomic concept. As you can see here, our group contains 4 members, and for the first members, we have Nur Ain Natasha binti Muhammad Zaid, Nelly Batrisha binti Nasharuddin, Auni Nabiha binti Azli, and the last one is Aslah Nur Husna binti Muhammad Asri. For the first subtopic in this chapter is classifications of matter. The classifications of matter are based on physical properties such as solid, liquid or gas, and compositions including atom, molecule, substance, element, compound or mixtures. First, we will start with atom. An atom is the smallest particle that differentiates a certain chemical element. When an atom of an element is divided, it ceases to be the element. Examples of atoms are sodium, iron, gold, oxygen, hydrogen, chlorine, and carbon. Next is molecule. A molecule is the smallest indivisible portion of a pure compound that retains a set of unique chemical properties. A molecule consists of 2 or more atoms, and these atoms are bonded together. Examples of molecules are oxygen, hydrogen, chlorine, ozone, and water. The next one is substance. Any sample of matter can be classified as a pure substance or a mixture. A pure substance can be either an element or a compound. The composition of a pure substance is definite and fixed. Examples of pure substance are pure water, which is compound, and a pure gold, which is element. The next one is element. A chemical element is often called an element. It is a substance that cannot be divided or changed into different substances by ordinary chemical methods. The smallest particle of an element is an atom, which consists of electrons centered on a nucleus of protons and neutrons. Examples of elements are metal, which contain iron, gold, silver, and mercury. The next one is gases, which contains oxygen, chlorine, nitrogen, helium, and neon. Noted, gases such as oxygen, chlorine, and nitrogen are elements that exist as molecules. The last one is non-metal, which contain carbon and silicon. The next one is compound. A chemical compound is a chemical substance formed from 2 or more elements with a fixed ratio that determines their composition. For example, the hydrogen monoxide is a compound composed of 2 hydrogen atoms for every oxygen atom. And the last one is a mixture. A mixture is a combination of 2 or more chemical substances. The substances remain chemically distinct, retaining their particular composition and properties. There are 2 types of mixtures, for the first one is heterogeneous mixtures, it doesn't have uniform properties throughout. For example, a mixture of oil and water, a mixture of nuts and cakes. And the last one is homogeneous mixture, it has a uniform composition and appearance throughout. For an example is a cup of coffee, a mixture of alcohol and water, and the last one is a solution. For the next subtopic in this chapter is atom and ion. An atom consists of 3 subatomic particles, which are electron, proton, and neutron. All atoms can be identified by the number of protons and neutrons. The atomic number, which is Z, is the number of protons in the nucleus of each atom of an element, which is Z equal to P. In a neutral atom, the number of protons is equal to the number of electrons, which is P equal to E. The mass number of which is A is the total number of neutrons and protons present in the nucleus of an atom. In general, the mass number is given by mass number A equal to number of protons plus number of neutrons equal to numbers of atoms plus numbers of neutrons, which is Z plus N. The next one is the denotations of atomic and mass. The denotations of atomic and mass number of an element, which is X, are as the following. The denotations of 3 isotopes of hydrogen atom are as in figure 1.5. Isotope has same number of proton but different number of neutrons. An ion is an atom or group of atoms with a net electric charge. As you can see from figure 1.6 is the ionization process. There are three types of atoms. The first type of atoms is neutral. It has the same number of protons and electrons. The second one is negatively charged. It has more electrons than protons. And the last one is positively charged. It has more protons than electrons. As you can see from figure 1.7 is the differences in the number of protons and electrons in a neutral atom, a cation and an anion. A cation has fewer electrons in its electron shell compared to the proton in its nucleus. Anions are negatively charged ions. An ion has more electrons in its electron shell if compared to that of proton in its nucleus. The next is the combination of positive and negative ions produce an ionic compound with a zero net charge. That's all from me. I will pass this presentation to Auni Nabiha.
Thank you so much, Nelly. Hi, my name is Auni Nabiha Miti Azli, and I'm here to talk about atomic and molecular mass. Atomic mass is the mass of one atom expressed in units. Atomic mass unit AMU or U, where 1 AMU is equal to 1/12 of the actual mass of the carbon-12. Atomic mass is also known as relative atomic mass. Most elements have several naturally occurring isotopes with differing percent of abundance. The atomic mass shown in the periodic table for an element is the average weight of all the masses in isotopes. It is known as average atomic mass. Next, we talk about the difference between atomic and molecular mass. Relative atomic mass is unitless. It is the atomic mass AMU divided by 1/12, the mass of a 1C12 atom. The most direct and accurate method for determining atomic and molecular masses is by using mass spectrometry. While relative molecular mass is also unitless. It is the mass of a molecule divided by 1 the mass of the C12 atom. So that is the difference between relative atomic mass and also relative molecular mass. Next, we move on to mole concept. Metals typically contains many atoms, thus a unit of measure called mole has been established for use in counting atoms. The mole is defined as the number of equal to the number of carbon atoms is exactly 12 grams of pure carbon-12. The actual number of atoms in 12 grams of carbon-12 is determined experimentally via mass spectrometry. This number is known as Avogadro's number. The standard value is 6.022 times 10 to the power of 23. Molar mass of a substance is the mass in grams of 1 mole of the compound. 1 mole of H2SO4 is equal to 98 grams and contain 6.022 times 10 to the power of 23 molecules of H2SO4. 1 mole of H2 gas is equal to 2 grams and contains 6.022 times 10 to the power of 23 molecules of H2. To determine the number of moles of any substance, the formula shown above is used. I think that's all from me. Let's move on to Aslah.
Thank you to Audi Nabiha. Now, I will continue this presentation for the next subtopic, which is name of chemical compound. The compounds can be divided into 6 categories, which are binary compounds, ionic compound, hydrates, polyatomic ion, salt, and acids. There are examples of name of chemical compound with their formula. The first one is binary compound. In this compound, we have 4 chemical compounds, for example, ammonia, NH3, and the nitrogen pentoxide, N2O5. Next, in polyatomic ion, we have 5 chemical compounds, for example, hypochlorite, ClO negative, and bicarbonate, HCO3 negative. The third one is hydrate. For example, sodium tetraborate decahydrate, Na2P4O7.10H2O, which is borax, and sodium carbonate decahydrate, Na2CO3.10H2O, which is washing soda. Next is acid. For example, phosphoric acid, H3PO4, and phosphorus acid, H3PO3. The last one is salt. For example, sodium fluoride NaF and sodium bicarbonate NaHCO3. Next, I will continue with the calculation of the oxidation number. The oxidation number of an element indicates the number of electron lost, gained, or shared as a result of chemical bonding. For any monoatomic ion, the oxidation number is equal to the charge on the ion. For example, the oxidation number of Na plus ion is positive 1 and the oxidation number of Cl negative ion is negative 1. In a polyatomic ion, the sum of oxidation number of all the elements in the ion must be equal to the net charge of the ion. For example, sulfate ion SO4 2 negative, the ion charge is negative 2. The oxidation number of the sulfur atom S is calculated based on the oxidation number of O equal to negative 2. So, based on the formula S plus 4O equal to negative 2 and the calculation we get, the oxidation number of sulfur is positive 6. In a natural molecule, the sum of oxidation number in all the elements in it must be 0. For example, CO2 molecule. We calculate using the same formula and the oxidation number of carbon that we get is positive 4. Formula. A chemical formula provides information on the composition of molecules and ionic compounds and is represented by chemical symbols. The symbols for the elements are used to indicate the type of atom present and subscript are used to indicate the relative number of atoms. There are three types of formula which are molecular formula, empirical formula and structural formula. The empirical formula represents the simple ratio of atoms for each element present in a compound. For example, acetylene C2H2 and benzene C6H6. The simple ratio are CH equal to 1:1 and the empirical formula is CH. Next, the molecular formula represents the actual number of the atom for each element present in a molecule. Last, the structural formula shows the bond between atoms in a molecule. Given that the mass or percent composition, the empirical and molecular formula of any compound can be determined according to the following steps. First, write the mass or percentage of each element in the compound. Second, calculate the number of mole of each element in the compound by dividing the mass or percentage of the element by the relative atomic mass of the element by using the formula number of mole equal to mass in gram divided by relative atomic mass. Next, divide each number of mole with the smallest value to obtain the simple ratio. Finally, write the empirical formula of the compound based on the ratio of the element. The last one is percent composition. The percent composition is the percent by mass of each element in a compound. The formula we are using is percent composition of element equal to N multiplied by molar mass of element multiplied by 100% divide by molar mass of compound. N is the number of mole of the element in 1 mole of the compound. I think that's all from me. Now I will pass to the next presenter, Nur Ain Zaid. Thank you.
Thank you to Asla. Stoichiometry is the quantitative description of the substance proportion by mole in a chemical reaction. The stoichiometric relationship represents the mole-to-mole ratio of reactant and products in a balanced chemical process. Chemical equations use chemical symbols to show phenomena occurring during chemical reactions. 2H2 in gas as reactant 1 react with O2 in gas as reactant 2 to yield 2H2O in liquid as product. The quantities of 2 mole of H2, 1 mole of O2 and 2 mole of H2O are the coefficients in the above equation and are called stoichiometric equivalence quantity. The second topic is balancing chemical reactions. So, in general, we can balance a chemical equation by the following steps. First, identify all reactants and products and write the correct formulas on the left and right side of the equation respectively. Second, begin balancing the equation by trying different coefficients to equalize the number of atoms of each element on both sides of the reaction. The coefficients can be changed, however, changing the subscripts will be incorrect as that will change the identifier of the substance. Third, next find the elements that appear only once on each side of the equation with the same number of atoms on each side. The formulas containing these elements must have the same coefficient. Therefore, there is no need to adjust the coefficient of these elements at this point. Then, find the elements that appear only once on each side of the equation by an unequal number of atoms. Balance up these elements. Finally, balance up elements that appear in two or more formulas on the same side of the equation. Check your balance equation to ensure that you have the same total number of each type of atom on both sides of the equation. Balanced chemical equation and stoichiometry is the quantitative study of reactant and product in chemical reaction. The unit for reactant or product could be in mole, grams, liters for gases, or other units. Mole unit is used to calculate the amount of product formed in chemical reaction. This approach is called as mole method. This method simplifies the stoichiometric coefficient in a chemical equation that can be interpreted as the number of mole of each substance. For the formula is number of mole equal to mass in gram per molar mass as G per mole. Next, this is the last subtopic for chapter 1, volumetric analysis. In this subtopic has another 3 content. So, the first one is concentration of solution. Concentration of solution contains 4 formulas. The first formula is gram per liter equal to mass of solute in gram per volume of solute in liter. The next formula is parts per million equal to mass of component in solution times 10 power of 6 per total mass of solution. Next is molarity is standard unit of concentration equal to mole of solute in mole per volume of solution in liter. For the fourth formula is the mole fraction. Mole fraction is a dimensionless quantity. Mole of component A equal to mass in gram per relative atomic mass A in gram per mole. Note that the ppm unit is commonly used as a measure of small concentration, for example, content of mercury in blood and concentration of Pb in water. After concentration of solution, there is dilution. Dilution is a process of adding solvent, usually water, to lower the concentration of a solution or stock solution into the range for the desired analysis. The relationship between molarity of solution with volume is M1 times MV1 equal to M2 times V2. M1V1 are mole of solute and volume before dilution, and M2V2 are mole of solute and volume after dilution. It is important to note that the units of V1 and V2 must be the same at the milliliter or liter. Last but not least, for chapter 1 is acid-base titration. Acid-base titration is a method to determine the concentration of an acid or base by neutralizing the acid or base with the known concentration of acid or base. Neutralization of acid-base produces salts and water. The reaction is acid react with base produce salts plus water. The stoichiometric relationship for the reaction is given by MA times VA per A equal to MB times VB per B. MA and VA are molarity and volume of acid. Respectively, MB and VB are molarity and volume of base. Respectively, A is the stoichiometric coefficient of the acid in balance equation. B is the stoichiometric coefficient of the base in balance equation. That's all from us. Thank you.